So get out those packets. Let's take a look. Today we're going to look at one relatively small topic. We are just going to look at multiplying radicals. Okay, so I'm going to go through a couple examples to remind you how to do this with square roots. We'll look to some higher radicals. How do we do this with higher radicals? And then tomorrow we'll talk about dividing radicals. Okay, so first of all, what's our product rule for radicals, do you suppose? What do you think the nth root of A times the nth root of B is equal to? If I multiply two radicals together that have the same index, what do you think we do? We haven't ever really talked, well, I mean, I guess we have a little bit with square roots, but your knowledge of properties of exponents ought to be helpful to you here. Let's get all the phones away, please. What happens if we multiply, let's look at our product rule for exponents. What if I have a to the n times b to the n? How could I rewrite that? Usually we start at this is the answer usually. We start with a quantity to a power and we separate it. But what's that equal to? What do you think? Any suggestions? Again, it's a little backwards. Typically, this is the reverse direction that we're used to seeing this property written. What is it? Yeah, it's a the quantity a times b to the n. So we can write it like this. Now, usually we start there, don't we? Right? And then we split it into a to the n times b to the n. But it goes both ways, right? They're equal. It doesn't really matter which side of the equation I start on. Okay, so given that, what do you think is true up here then? What do you think is true of this product rule? If we're going to multiply two nth roots together, what do you think we get? Nth root of a times nth root of b. What do you get? What do you think? Well, I bet you know the answer. How are you going to do that problem? Number 8. Okay, so yeah, we're multiplying. Look what we got here. We got a product of two numbers, 3 times the square root of 10 times -2 times the square root of 18. Well, we always talked about this in terms of inside numbers and outside numbers. So what's our answer going to be here? I've got the outside numbers 3 and -2. So what's that going to give me? The outside number, -6. I've got the inside numbers 10 and 18. So what's that going to give me? 180 inside, right? And remember, that's just ringing a bell. We haven't done this in a while, right? But we always talk about when we multiply square roots together, we multiply outside numbers together and inside numbers together, right? Okay, well, let's backtrack a second then. What did we just do? That's a square root is just a second root. We don't write the 2, but it's there, right? So then what is the nth root of a times the nth root of b? It looks to me like I've got two inside numbers there that are being multiplied. So what do? The nth root of a times b, right? Okay, easy. That's all we do. If we have like radicals, we just multiply the inside numbers together. Okay, so we already did number 8. That's no big deal. How about number 9? What do you think I do with a different kind of radical? So now it's a cube root. What do you think? Mackenzie, what would you do with this one? What do you think? What's your intuition telling you about this one? I bet you're going to get the right answer. Okay, okay, you could. You could simplify. Let's not. We have an option not to. Okay. So what do you think? There, there you go. We, okay, so 10 times the cube root, isn't it? Good. So we're going to multiply the outside numbers together and get an outside number of 10. Okay. So what's going to be next then? I've got a cube root of, what do you think? Miranda, what would you do with the inside numbers? Multiply them. Yeah. 9 times negative 24 is giving us negative 216, right? So we'll multiply these guys together. Make sense? Okay, now what do you think we do? Now that we've multiplied all these together, I multiplied the inside numbers together. Now what do you think you do, Mackenzie? Now we simplify, right? Good. Okay, so now one other thing we can do here that I like to do, this is kind of a good habit to get in, is when I have a negative inside a cube root, what can I do with that? What is the cube root of a negative number always going to be? Like, what's the cube root of, no, of a cube root, not a square root. A square root of a negative number is going to give you an imaginary result, right? It's going to give us a negative, right? With odd roots, we can take an odd root of a negative number and we just get a negative answer, right? So one thing I always really like to do is if we've got an odd root of a negative number, let's put that negative outside. It just makes it a little bit easier. It's easier to think about a cube root of a positive number than a negative number. Agreed? Everybody see what I'm doing there? Okay. So then we get this instead. We took the negative out. Now we've just got the cube root of 216. Okay, so we get a little more practice. This is the stuff we did back on Thursday, right? Okay, so let's simplify that cube root. What do I do? Say it again. The cube root of that, right? So how do I simplify that? Got to factor it, don't we? Yeah, we got to make a factor tree. Okay, so 216. So Arson, start us off here. What's a number that divides into 216? 9 does. Good. Good job. We got a bigger number. We don't want to really do 2 because then our factor tree gets really long. You can, but let's pick something a little bigger if we can. 2 plus 1 plus 6 adds up to 9. If the sum of the digits is divisible by 9, the number's divisible by 9, right? So we can pull a 9 out. Okay, let's see, 9 goes into 21 how many times? 2, with how many left over? Okay, 9 goes into 36, 4. Okay, well, the 9 we can break down. And remember, when we're dealing with cube roots and fourth roots and higher roots, we want to break stuff all the way down to prime factors. It's just easier rather than trying to get, like, remember how with square roots we sometimes would avoid having to break things down too far and we'd get bigger couples, and that was a little bit sort of kind of a shortcut of sorts. Let's not do that with higher roots. It just gets too confusing. So we'll break that 9 down to a 3 and a 3. How about 24? 6 and 4, okay? And the 6 breaks down into 3 and 2. And the 4 breaks down into 2 and 2, right? Okay, so now let's do our trick. Whenever we're dealing with these, these higher roots or radicals, let's write our string out in increasing order of factors, right? So we've got this down to the point where we've got only prime factors, so we're done with our factor tree. Well, 2 is, we start with 2's. I've got a string, it looks like, of 3 2's multiplied together, and then I've got 3 3's multiplied together. What's my rule for simplifying a cube root? Instead of couples go out, singles stay in, what do we say for cube roots? How does that one go? Well, triples go out, everything else stays in. right? Just like instead of couples go out, singles stay in, now we've got triples go out, everything else, meaning singles and couples, stay in, right? Okay, so what do we got here then? Well, it looks to me like we've got a triple 2 and a triple 3 and nothing else, right? So this cube root of negative 216, do I have anything inside? Nothing, right? I don't even need the radical, do I? Everything comes out. Okay, so we just end up getting our negative 10 times 2 times 3 is what? Negative 60? Does that make sense? Okay. Let's try one more of those, then I'm going to have you guys go to the board and try one. Let's try how about this one? What do we got here? Yeah, hey, let me check one thing. Did I do? Oh, never mind. Okay. Okay, negative 3 times negative 1. Look at my outside numbers, right? My outside numbers I'm going to multiply together first. My outside numbers are negative 3 and negative 1, so I get a positive 3. What's next? Abby, what am I doing next here? Say it again. Multiply the 64 and these. Yeah, the inside numbers get multiplied together. Okay, that's going to give us a big one, isn't it? 64 and 8, what is that? 512. Now, what do I have to do with to simplify that radical? What am I going to do there till I say I want to simplify that fourth root? What do I have to do to simplify that fourth root? What did we do last time? We had a cube root. And we made a factor tree, right? Same like we do with the square root. So what do you think my first step is? Factor tree. Okay, only what's our saying going to be? For square roots, couples go out, singles stay in. For cube roots, triples go out, everything else stays in. What is it for fourth roots? Quadruples go out, everything else stays in. Good, okay. All right, so let's try this then. We've got our 512. Oops, that's bad color. Okay, what's a number that goes into 512? What's a good number we could do 2, but we have a little bigger one? Arson knows. What is it? 8 does. Yeah, 8 does. That's true. Yeah, that's good. 8 does. We can do 8. That's fine. Okay, so we get an 8. 8 goes into 51 how many times? Okay, 64. Good. We'll just jump right to the answer. 8 times 64. Okay. Let's see. 8 breaks down into, we'll just do that. 8 breaks down into what? 2, 2, 2. Yep. 64 breaks down into 8 and 8. Sure. And then we've already done 8. 2, 2, 2. 2, 2, 2. That's a lot of 2s, isn't it, right? So if we write this whole thing out, then we got it factored into its prime factors. Let's see, what do we get there then? So we get 2 times 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 2. Lots of 2s. Okay, you guys already told me quadruples go out, everything else stays in. There's a quadruple. There's a quadruple, so those guys go out. There's a single, right? So we end up with, we've got our 3 that's already out front. Outside, we're going to get a 2 and another 2. And inside, we get a 2. Right? So there's our answer then. We just end up with, let's see, what's that give us? 12 times the 4th root of 2. Okay. Give me thumbs. Is that making sense? Okay. Why don't you guys try one of these? Let me pull up an example. Let's try. Okay. Oh, where'd that go? There it is. Okay, let's try this guy. Ooh, I like this one. Okay, this is going to force you to think about adding and subtracting radicals also. Okay, try that. Now look carefully at those radicals. Actually, no, I don't want to do that one. I picked the wrong one. Darn it. Sorry about that. False alarm. False alarm. Okay, we're going to do this one. Okay, that one. Try that one. Oh, the other. This is better. I like this one better. Okay, that looked pretty good. The one thing I would say, looking out at the work on the boards, the only thing I saw that I thought could have been slightly improved would have been to take all those numbers in a couple cases and write those out in a row. Just because when you start to get tons of them like that, it's easy to make mistakes with what goes out and what stays in. Everybody got to hear just fine. People pulled the negative out with odd root of a negative number. The negative comes out front. That's great. And then we ended up factoring the 432 and got all those numbers. But if we write them out in a row like this, look how easy it is. Triples go out. Well, there's a 222. There's a 333. What's left behind? The only straggler is that 2, right? So we end up then with negative 28 times what goes out? 2 and a 3. What stays in? A 2. And then what'd that give us? Oh, I forgot my negative. So we got negative, what was it, 168? That's it. Okay. Now, what would we do with, just quick question, I have to do this whole problem. What if I had a 4th root of negative 24 times a 4th root of 100? Anybody see a problem up there? There you go. Look at that. I have an even root in a negative number, so the answer is Non-real, right? You'd have a choice in your answers. We're not really going to get into the I's here, right? And at this point, we've already done some work with that. We'll go back to it at some point too. But all we're looking at here is we're looking for real, simplifying these into real numbers. And if we can't simplify these into real numbers, then we just choose the selection that says no real solution, or there's no non-real number or something like that, right? Okay, good. All right, last issue is what happens if we multiply out expressions, and specifically binomial expressions, right? And this is something, why binomials? Because we deal with these a lot, right? What happens if we have to multiply out binomials that involve radicals? Well, what would I do with number 18? I've got the quantity 4 minus the square root of 5 squared. What do I do? FOIL it out? Okay, we can. That's fine. We could rewrite this as a product and FOIL it. That's fine. We can do that. Okay, so if I FOIL this out, if I distribute the 4, what am I going to get? Okay, 4 distributed to the 4 gives me a 16. 4 times negative the square root of 5. What's that? Yeah, good. We just multiply outside numbers and inside numbers, right? So what are my outside numbers? 4 times negative 1 is negative 4. And my inside numbers, all I've got is a 5 for my inside number, right? Let's get those phones away, everybody. Okay, now if we distribute the negative radical 5, what's negative square root of 5 times 4? What's that going to give us? Johnny, what's that giving us? Yeah. Times the square root of 5, right? Good. Outside, multiply outside numbers. Negative 1 times 4 is negative 4. Inside numbers, there's only one, square root of 5. And then finally, what's negative the square root of 5 times negative the square root of 5? Yeah, good. I get positive 1 times the square root of 25, which is 5. Okay, so we can just replace that whole thing with 5, and then I just combine like terms, right? So now let's see, if I combine like terms, I've got 16 plus 5 is 21. And are those combinable terms, those radicals? Yeah, they are. They're like radicals, aren't they? They're the same type of root. They're square roots. And I have the same radicand. I have 5s under both my square roots. So yeah, those are like roots. So there's my answer, right? 21 minus 8 times the square root of 5. Oh, yeah, you bet. Nice. Look at this. I think I'm going to go with that guy right there. Is that a blueberry one? Yeah. Nice. Okay, perfect. Thanks. You too. Okay, so was there another option with this? Does anybody see a shorter cut than we just made with something like that? Is there a pattern we could use? You guys remember that? Pascal's triangle stuff? That worked. It's fine. Did you block out Pascal's triangle? Did you? Okay, well let's bring it back. Let's resurrect Pascal's triangle here. What's the pattern that we would use if I've got a binomial, right? So a binomial just is the form a plus b, where in this case a is 4 and b is negative radical 5. What's my pattern for that? If I have a plus b quantity squared, anybody remember how that expands? That's exactly it, right? Pascal's triangle stuff. So why is that so useful to us? Well, it's useful to us because, look, we're just saying A is equal to 4 and B is equal to negative the square root of 5. And that's an easier way to expand this, isn't it? Right? Then that would give me 4 minus radical, oh my goodness, 4 minus radical 5 squared. If I follow that pattern, is just going to equal A, which is 4 squared, plus 2 times a, which is 4, times b, which is negative radical 5, plus b, which is negative radical 5 squared. Look how easy that is, right? That just gives us 16. I got positive times negative is negative. 2 times 4 is 8 times square root of 5. And negative the square root of 5 squared is what? What would that be? 25, yeah. So that got us to our answer, maybe just a little bit quicker here. What the heck happened? Did I not add this stuff up right? Oh, hang on. That's not 25. What is that? Yeah, it's just going to be a 5, isn't it? Negative the square root of 5 squared. I don't know what I was thinking. Negative times negative is positive. Square root of 5 squared is 5. So that should have just been that, shouldn't it? So then when we add all this stuff up, we get our 21 minus 8 radical 5 that we got before. Okay, no big deal. All right, so what about one like this? Really no big deal. Same kind of thing. What would I do here to multiply these binomials out? Foil it out, sure, foil it out. Okay, so Miranda, what do I get when I distribute, when I'm foiling, if I distribute the 6 radical 6 to the radical 6? What's that first product going to be? 6 times the square root of 6 times the square root of 6. It is. It is. It's just 36, right? Because I get my outside number 6 times the square root of 36, which is just 6, right? Okay, so that one's going to turn into 6 times 6 is 36. How about the next one? We distribute to the square root of 2. Abby, how am I going to deal with that? 6 radical 6 times the square root of 2. Okay, good. I get a 6 on the outside. What goes on the inside? 12. Beautiful. 12. Okay, so I'd have to simplify that one a little bit, wouldn't I? I could go over here and make a 12 factor tree. 12 factor tree. What's that factor into? 4 and 3. 4 is a good choice because 4 gives us a couple of 2s. There we go. So this one's going to break up into 6 times outside number of 2. And I got a single 3 left over. Okay, keep going. Pushing on here. How about this one? Negative 6 radical 2 times the square root of 6. What's that going to be, Mackenzie? Okay, so I've got an outside number of negative 6. Inside, whoops, I want to do it up here, don't I? Inside number of 12. Okay, and we already did 12, right? We already know 12 is 6 times 12 gave us an outside number of 2 and an inside number of 3. And then finally, last one, negative 6 radical 2 times radical 2. What's that going to give us? Who haven't I picked on in a while here? Twesse. What's that going to work out to be? I've got this guy times this guy. Okay, and you're getting that because you're doing negative 6 times square root of 4, right? And square root of 4 is 2. Good. So that's going to give us a minus 12. If we just simplify each of those individual terms, so we had our 36. Here, this would have given us, if I multiply those outside numbers, I get a 12 radical 3 minus 12 radical 3. minus 12. Anything good happen there? Yeah, look, those guys cancel, don't they? Yeah. So he's gone, he's gone. And our final answer then just looks like 36 minus 12, which is 24. Okay. Give me thumbs on that. How we doing? Okay, good. Assignment is up, or it will be in about a minute or 15 seconds if it's not already.